Hey, so today we're going to be talking about air, and we are going to be talking about how air is a gas, and then we will be doing some science experiments within that. So, what evidence proves that air is matter? So, the three states of matter that we will look at are solids, liquids, and gas. And I have a balloon here. Right now, the balloon is not taking up very much space, but I'm going to go ahead and blow up the balloon. Now I have filled this balloon up with air. So previously the balloon wasn't taking up very much space, but now the balloon is taking up space. So that is an example that shows us that air is matter because it takes up space. Additionally, you can feel it. So if I were to take this balloon and blow it, you could see it moved my hair. I could feel it on my face. And it is also a force. It can be used as a force. For example, you just saw it was a force to move my hair. The next part that we're going to be talking about with air today is air resistance. Earlier this year, we did talk about air resistance, and we are going to do a quick investigation to find out which object has more air resistance. So go ahead and make a prediction right now. Do you think the pencil has more air resistance, or do you think it's the feather has more air resistance? We are going to find out right now. Here we go.
Hey guys, you might be wondering, why is my teacher outside wearing a sushi costume? Well, I think I'm wondering the same thing. The sushi costume has nothing to do with the science that we're going to be doing today. In fact, the two things in my hand are what have to do with what we're doing for science today. So I have on one hand, I have a pencil. In my other hand, I have a feather. I am going to go ahead and drop these two items, and we're going to watch to see what happens. All right, get ready, scientists. 3, 2, 1, drop. Oh, the pencil landed and the feather landed. Stop.
All right. So as you can see, the feather has more air resistance. It has more air resistance because it takes longer to fall to the ground. So the pencil falls at a faster speed, at a faster rate than the feather, because the air is catching the feather and causing it to slow down. We're going to go ahead and think about parachutes. So I have put in my link for today, directions, so how you could make your own parachute. It's very simple. All it is a napkin. You take it, you unfold it, you attach some strings to it, and then attach a paper clip. You could attach a minifigure. You could attach a little army guy to the bottom of that. Again, very simple design. You can tape it to the edges, your string, and then you would have your own little parachute. If you don't have a napkin, you could use a baggie and just open it up, or a Kroger bag. So we are going to do an investigation to think about what would happen if we took a parachute and drop it. Is there air resistance? And the second thing that we're going to experiment with is, what do you think would happen is if instead of opening up the parachute, we bundle it up? Would it still fall at the same speed as a parachute that is all opened up? Let's go ahead and check it out.
Scientists, thanks for joining us again for our second part of Get Some Air. Yes, I'm still wearing this sushi costume here, but I've been joined by my co-scientist, Drew. Hey, Drew, what do we have here in our hands?
Parachutes.
Parachutes. So on my parachute, I have 2 paper clips on the bottom. On Drew's parachute, he has 1 giant paper clip on the bottom. What we're going to do is we are using these parachutes to investigate air resistance. Say with me really loud here, Drew. Air resistance.
Air resistance.
That wasn't loud. Say it real loud. Ready? 1, 2, 3. Air resistance. All right, so we're going to open up our parachutes. And are you ready, Drew? Yeah. We're going to go ahead and drop them on 3, 2, 1, drop. Oh no, sushi costume. All right, boys and girls, so as you can see, our parachutes caught the wind. They did not drop quickly. What I'm going to do is I'm going to go ahead and just do really quickly I'm going to show you what would happen if I had mine bundled up and not acting as something to catch the air, to be resisting the air. You keep yours open. All right, and we'll go ahead and you have yours open. Okay, you ready, co-scientist? Hold your hand in here. Alrighty, and we're going to go ahead and see if there's a difference in how they drop this time. Ready? What are we learning? Air resistance. 3, 2, 1, drop. Oh, yours floated. Mine dropped like a ball. All right, so the reason that they dropped differently is because mine had less air resistance and Drew's had a lot of air resistance. All right, scientists, thanks for joining me today.
Bye.
Hey, scientists, thanks for
We
joining
don't
me.
need to watch that again. All right, and again, you can do the same experiment at your house. Just to go ahead and wrap it up, we'll put me up here in the corner. So air resistance is when an object moves through the air and is slowed, it is always slowed down by the air that is in the way. That's called air resistance. So as you found, some objects have more air resistance than others. Objects that move more in the air have more air resistance. And for example, if a balloon, if I had this blown up, I let it go outside and the balloon fluttered through the air, it's because it has a lot of air resistance. Unlike if I went outside and I had Drew's Lego creation and I were to drop it, it's not going to float through the air. It's going to drop pretty quickly because it does not have a lot of air resistance. So scientists, what I would love for you to think of today is, can you think of an object that has a lot of air resistance? Can you think of an object that does not have a lot of air resistance? So for example, my balloon, if I blow it up, it has a lot of air resistance. Drew's Legos, not as much air resistance. All right, thanks for joining us today to learn about air is matter, air is a gas, and also learning about air resistance.